So, going back to the learning objective where I underlined some numbers and some words for us. The first word I underlined was whole numbers, and in order for us to use this terminology, I want us to write down the definitions. So we're going to write whole numbers, and I've already started the definition for you. In your binders here, the next clean sheet of paper right here is where I want you to write these notes. Do you need a pencil? Yeah. Here's some pencils. So I've already written whole numbers down here. Let's write them down, and the next one's going to be unit fractions. I'll write that down as well, and then after you copy it, we'll take a second, discuss it.
Wait, is 0 a whole number?
Is 0 a whole number? Yes, it is.
Oh.
It is a whole number.
That's confusing.
Well, I tell you what, we're not going to deal with divided by zeros today. So that question I can look up and get back to you on, all right?
Okay.
All right. So let me write down unit fractions.
Do we have to write down that unit fractions?
Yes. Okay. So finish copying that and then we'll discuss it in a second. looked up your question about zero being a whole number, while they're finishing up, it says the definition of a whole number is, there are three definitions of whole numbers in math. They're all integers, which means they're not fractions. They're, okay. It says they are non-negative, or another way of saying that is they are positive. Now, the tricky part here is zero is definitely not negative, right?
What do you tell me? It's like the 0 and negative.
Negative would be anything below zero, right? Think about temperatures. It's 0 degrees outside.
Kind of weird.
It is weird, and it's difficult when you think about it. It's a little bit confusing, but mathematicians consider zero to be a whole number.
Because I just seen it like it's a number in between.
No, it's a good question that you're asking, though, because now you know, right? So those are the requirements. It's zero is not negative. It's technically not positive, but it's not negative. So
It's a dumb number.
kind of. So I see the pencils are down. We're going to talk about it here. Whole numbers are the positive numbers on a number line, starting with 0 and going positive way. 1, 2, 3, 4, and forever. It says no fractions. So that makes sense if we're going to divide whole numbers by unit fractions. No fractions, right? Otherwise it would be dividing fractions by fractions. Unit fractions, these are a rational number, and I underlined that for a reason. They're a rational number written as a fraction. The numerator and denominator are both positives, like 1 over 1, 1 over 2, and it just keeps going. Okay. Now the reason I underlined it rational is because it has to have like a definitive ending. The best example that I can think of, you guys have heard of the Greek letter pi before.
Yeah.
What do you know about pi?
Just a 3 and a point.
Yeah, 3.14, and then it just kind of keeps going on forever, right?
Yeah.
So if somebody asked you to name all the numbers in pi, could you do it?
No.
No, because it goes on forever. There's an infinite amount of numbers. With this says 1, here's your start, here's your ending, okay? This has a definite amount inside of it, because they have a start and an ending. So the unit fractions have to be fractions like these. These are unit fractions. So if somebody says, what's a half? You can say, this is a half. Here's the start, here's the ending. Half of a whole. This is another unit fraction. All of these in our kits. All of these in our kits here. These are all unit fractions. They are the smallest units that we can get with these numerators and denominators. Notice also that they're all positive, and that's what we're looking for right here, because it says the numerator, the top, and the denominator, the bottom, are both positive. So, when it says I can divide whole numbers by unit fractions with fraction kits, I'll know I've got it when I can divide that without the pictures, or the pieces here. So what I want to do here is I want to pass out some dry boards here. I'm actually going to pass these out in a second. I'm going to model for you just a little piece. And what I say the learning objective is to divide a whole number by a unit fraction. Here's an example of what it would look like. Okay? Devin? Here's my whole number. Here's my unit fraction. I'm dividing this by this. Okay? Say it louder. I'd love to hear that.
No, I get it.
No, I get it.
That was easy.
That's what we're doing. We're dividing whole numbers by unit fractions.
Wait, wouldn't that be 3/4?
Would it be 3/4?
Yes.
I don't know. We're gonna have to figure that part out. You guys have pieces here, and what I want you to see here is, here is my whole number. Here's my 1.
Yes.
And remember, you guys are just watching here, and I need a quarter. Here's some quarters right here. Okay? So, would you mind kind of holding this up, just modeling it for me?
Like this?
Watch. Yeah, kind of like that. So, if this is a quarter right here, Simon, if I'm dividing this by this, how many pieces is this whole number going to be broken up into?
4.
Right, because 1, 2, 3, 4, right?
And then dividing
I know the
it
answer.
So,
Give me 1/4.
the answer to 1 divided by 1/4 is 4. So when you take a whole number, you divide it by a unit fraction, you get 4 pieces.
Oh.
Okay?
So how many times that 1/4 goes in that amount?
Yes. How many times does the 1/4, the piece of 1/4, go into the whole number?
But how do you get a bigger number from that?
What do you mean?
If you go from a 1 and a 1/4 to a 4.
Well, we just showed it to you, remember? Here's your 1. We're dividing it by this piece, right? So if I had a pair of scissors and I cut right here,
Okay.
that would be 1 piece, right? I'm dividing this piece into,
4 pieces of that.
yeah,
Oh, yeah.
okay? So it equals 4. So another example. Let's try this one. 2 1/3. 2 divided by 1/3. So this says 2 what?
2 holes.
2 holes. So let's see, 2 holes. Can you give me 2 holes? Why don't you put those together, lay them down right here. And it says we're dividing it by 1/3. So I see some thirds over there, he's got some thirds. If I divide 2 holes by 1/3, how many pieces am I going to get?
6.
6. So you start to see how we do this operation with the fraction,
So
kids?
much easier.
You see how you start to do it? You can visualize it now? Okay. So at this point, I would like to pass out these to you.
I know how to make it easier.
Oh, hold on. Hold on one second. Don't ruin it for everybody, right? I'm glad that you're starting to see a pattern, and then everybody's going to get that light bulb. So don't take that moment away from them, okay? So pass those out. Okay. First one that we're going to do is 1 divided by 1/6. So, each of us have enough pieces to do this one. You each have 1 whole number. Each of you have 1 whole number, and then I want you to divide it by the fraction 6. Okay?
That's really easy now.
Yes, I told you it was going to be super easy, right? So I need you guys to get those blue whole pieces out and take those orange 6th pieces and do it.
Where's all my 6? I got robbed.
He's got a lot of them, okay?
And I had all of them. He robbed me.
So you've got 1 whole divided by 1/6. Khalil? I see you're done. He's almost finished up over there.
How many 6 go into a hole?
Yeah, that's another way of asking. I like that question. How many 6 go into a hole? Say it again. 6. So you just divided 1 by a 6, and you got 6 pieces.
And actually, how do you get how do 1/4 go to a 4 hole?
Mm-hmm.
You get the pattern?
Don't give it away. Okay? Don't give it away. So let's try another one. So, yep, you can erase it because I saw your work. Let's try another one. Let's do.
Do the 4th?
We're going to do a big one. And this one you guys are going to have to work together, the whole group, okay, to build this one. Because it involves a lot of whole numbers.
3.
3 divided by 1/5. Before you do it, before you actually get out the whole pieces from the kits and do it, I want you to estimate how many pieces you think it's going to be. What's the answer going to be? If you divided 3 wholes by 1/5, how many pieces do you think?
You guys can't use pieces.
Hmm?
You can't use pieces too.
No, they can use the pieces. I'm just trying to estimate first. How many pieces do you think it's going to be? 3?
15?
15?
6.
6.
1.
He says 1. Okay. So, in order to do this, how many of these are we going to need?
3.
3. So let's lay them out. Here's 1.
Here's 2.
Here's 2. Here's 3.
Alright, slide them on down. And then we're dividing it by 1/5. So let's get the 1/5 pieces out. Do we have 1/5?
No, they aren't.
Oh, we do not. How can we do this then?
Or we could use
Basically-
what we already know
We can use
to
1/6.
solve it.
And that's right.
Like what we can do, we can put 6 down, just divide it by 1 for every 6. And then we have an answer.
Say it again. And listen to him, guys.
We
Listen.
could use our 6's,
Okay.
and then we could divide them by 1 for every 6.
So how many pieces would go on one blue strip?
Well, there will be 12 for 2, and then 18.
No, we're not using sixths, remember, we're using fifths.
I know, and we could take away 1 for each 6, and we have our answer.
There'll be 5 on each.
Why don't you show me, and then I think he'll offer a suggestion.
Okay, 1, 2, 3, 4, 5.
Okay, so 5, right? Because we're supposed to be doing it with fifths, right? Okay, so that whole piece is divided up, correct?
But they wouldn't equal the same because they're 1.
Trying to cover up the whole 3.
Okay, so let's use a picture then, since we haven't talked about pictures yet. Instead of using these pieces, since we don't have a fifth fraction piece, why don't we draw a whole rectangle like this? Draw a rectangle on your boards.
That should be estimated.
It's okay. How many pieces am I splitting this up into?
5.
5. So can't we just make
Yeah.
5 squares?
Yeah, I give it hands. That you can basically multiply.
No, I don't want you giving any hints yet.
1, 2, 3, 4, 5. Okay.
Okay.
So 15. It's just 15.
And how did you get 15?
Because there's 3 of these.
There's 3 holes, right?
And
We only
5
did
of
one.
those. 5 for each one.
So, Khalil, if this is 1 hole and I divided it by 5 pieces, I've got 5, right? And then I need to do it 2 more times to get 3, correct? So I'd have like 3 more long rectangles. How many pieces would I have? 15. Right. So that's your answer. Now you said 3, you said 6. I don't remember how much you said.
I said.
You
I
said 2.
15.
And you said what?
I said
15.
15.
1. I said
Okay.
1.
I did too say 15.
So you starting to notice anything?
Yes. I
Okay.
was right.
He noticed it, and now you noticed it, so 50% of you guys know it now. Starting to notice it? The pattern?
No, you really don't see it.
No? It's okay. So, what we're going to do here is I'm going to transition here from these boards. So you can cap these, clear off your board. And put these boards down here. Take one of these and pass it around. 2, 3, 4. Okay. I'll take those. those, thank you. Alright. The instructions at the top say, solve each problem by marking off the fractions. The first is completed for you. Look at number 1. Is it or is it not the exact same thing we just did with the boards? We took a whole number and we split it up into the pieces, correct?
Mm-hmm.
Alright, so look at number 1. It says 3 divided by 1/7. Could we do that with our fraction pieces? We have a 7th magnet piece, right?
I don't think we have the 7th
No?
magnet.
Oh, we don't have a 7th either. Well, that's a good thing that we got this paper here. And we know the skills to divide it. So what do you notice about problem number 1 here? It's got a hole, and a hole, and some other stuff. What do you notice about the other stuff? Look for a pattern here. Devin, I need you looking at the paper, okay? He's going ahead because he's figured out how to do it. But he's still going to check his answers and check his partners, okay? Simon, I noticed you counting the squares on the bottoms of that. How many squares did you count? Can you count them again? And then you count them also, okay? Go all the way to the end. How many do you got? 22. He's got 21. It's 21. Okay? It's 21 squares. Notice that the fraction said 1/7. How many squares are in each hole? 7. So, you've got the 3 holes on top. You've got the 7 squares underneath each hole. So when you divide 3 by 1/7, how many squares do you get altogether? 21. Perfect. So that is your answer, right? 21 down there. Okay, so look at number 2. On number 2 through 10, they don't provide any of the squares on any of these. So I don't know if you did that. I saw the answers here, but I don't know if you did that part. Yes, please.
Okay.
So if you could, look at number 2. It says 4 holes divided by 1/3 unit fractions. So how many squares are going to be underneath each hole? Devin, how many squares?
For number
Number 2.
2, how many squares?
Yes.
12.
How many squares per whole unit?
Per
Yes.
3.
And you know that because, where'd you get that number from?
It came from 1/3.
Right, it's the denominator from the unit fraction. Thank you.
Did you do like exactly?
No. You're just eyeballing, okay? How many pieces? So he's got 3 pieces now per one. So Simon, how many squares do you have underneath each whole piece?
What does number 7 say?
See that number 3 right there?
2 divided by
That means
1 over 7.
Every one of these blank ones, you're gonna put 1, 2, 3. So
It's a-
3.
You should say 5.
He has a 5, I got 3.
So you need to get rid of one of these. So you have
1,
1, 2, 3.
2,
1, 2, 3.
5.
1, 2, 3. So each one of these has 3 pieces in it. Okay? 1, 2, 3. 1, 2, 3. 4, 5, 6. 7, 8, 9. 10, 11, 12. Okay? So that's your answer right there, 12. Is that what you got? Devin, are you done with this?
Almost.
Almost?
Next one to go.
I don't know. Number 3, 5 divided by 1/3. So how many pieces are going to be in each whole for this one? Sure.
Which one are we on? 5?
Number 3.
Number 3,
I heard you.
it'll be 3.
Yep. Underneath each hole, you need to have 3 squares. Hmm? Okay. I want you to be checking your work though.
Okay, I'm done. Okay.
Okay. How much, what do you get?
Keep it, so you have to check your work. I think keep it and check your work.
15? Nice. Okay, so we all got 15. Let's do one more, make sure you got it, okay? Let's go to number 4. We got 5 holes divided by 1/4 unit fraction. So how many pieces are going to be in one hole? 4. Okay. All right, so you've divided it up one hole now, right? I'm going to stop you before you go the rest of the way. How many squares total are you going to have before you finish making all those squares? The question is, I stopped you before you got a chance to complete all of these squares. Do you see how many squares are in one hole? How many squares are in the entire thing? Can you figure that out without using the picture?
This can be a drink.
Yes. Now, how did you get 20? Say it again.
It's multiplication.
And what did you multiply? Okay, now let's be really specific. Because you used the right numbers, now I want you to use the right math vocabulary. Okay? Because we're all going to write this in our notebook for our math journals.
Can we do it now?
Yes. Tell me what you just said, and I'm going to help you clean it up.
Wait, what's the main words?
Okay. So use multiplication Okay, so we're multiplying something and something. What am I multiplying?